backwards on the unit circle. In our first example on the paper is done for us, and it says list all of the angles. So this time we know the value of the angle, and we need to go back and figure out what theta is. One thing to notice is that we're going to be working from 0 is less than or equal to theta is less than 2 pi. So we want to look at the angle of 0, but we're not going to look at 2 pi. This says less than, doesn't say equal to. So from 0 all the way over to 2 pi, but not including 2 pi. And again, what happens is we're given the value. So we're given the value where cosine is radical 3 over 2. So if we need to, we can look at the unit circle. And again, our goal is to not look at the unit circle. But to kind of get our bearings here, we might look at the unit circle. And where is cosine? What angles have cosine with the value of radical 3 over 2? Well, we look at our unit circle and we see that pi over 6 has cosine is radical 3 over 2. Positive, by the way. And then way over here at 11 pi over 6, we see a positive radical 3 over 2. Well, I'm going to jump around a little bit, but I am going to start with problem number 2. And hopefully the board changes pages. But it says sine of theta is radical 3 over 2. So remember, sine on our unit circle is the second value. So where on our unit circle do we have a value of radical 3 over 2 that's positive in the second position? Abby? Pi over 3. 2 pi over 3. So we want to make sure to list them all. Let's try another one. I'm going to do 4, and then I'm going to come back to 3. So cosine of theta is negative 1/2. And that's why I say you might want to look at the unit circle. It's going to be in quadrants 2 and 3.
It's going to be 2 pi over 3.
2 pi over 3.
And 7 pi over 6.
No, if it's pi over 3 here, it's always going to be pi over 3. Again, that's where you might want to look at your unit circle. So 2 pi over 3 is negative, and what am I talking about with negative? All students take calculus. The C stands for cosine. Cosine in this fourth quadrant here is positive. All functions are positive here. So cosine is going to be negative in the second quadrant, where we see the S. It's going to be negative in the tangent quadrant, the T quadrant there. So our other function is 4 pi over 3. Again, our goal eventually is to do this without a unit circle, but we kind of have to understand what we're doing first before we start guessing. I don't want us to guess. I want us to know. But if we jump back here to problem number 3, tangent of theta is radical 3 over 3. So, is it pi over 3, pi over 4, pi over 6? It's going to be pi over 6. And this is a positive function, square root of 3 over 3. So what quadrant is tangent also positive in? It's actually in all students take. It's in the third quadrant. So here's our third quadrant. We want the function, so we've got pi over 6. So it should be 7 pi over 6. So if we jump over here to another example, number 7 is the cotangent. Well, I personally look at this from the perspective of the reciprocal. So cotangent of theta is the reciprocal of the tangent of theta, which means that we would be dealing with 1 over the square root of 3. And it's still plus or minus. We don't really like to have the radical in the denominator, so let's get rid of the radical in the denominator. So what we end up with is 1 times radical 3 is radical 3. Radical 3 times radical 3 is radical 9. And the square root of 9 is 3. So what we want to know is which angles, and it could be positive or it could be negative, have the values of positive radical 3 over 3. So pi over 6 in the first quadrant. In the second quadrant, tangent is negative, but what's that value that's pi over 6 in the second quadrant? It's actually 5 pi over 6 in the second quadrant. In the third quadrant, tangent's positive. What's the pi over 6 in the third quadrant? 7 pi over 6. Numerator is 1 bigger than the denominator. And now, Tracy, there we go. 11 pi over 6. 4 different values. So again, what we need to know is we need to know some basics of our functions, and then we can figure out where they are in the unit circle. So we know the value, we need to go back and figure out the angle. Same idea here on problem number 8. I personally don't have secant and cosecant memorized. I look at it from the perspective of their reciprocal. So the reciprocal of secant is cosine. So if we take the reciprocal of this function, then it's going to be 3 divided by negative 2 radical 3. And we want to get rid of the radical in the denominator. So the process is still the same. I'm just going to multiply by the radical. That's the part that I don't want in the denominator. I don't really want the negative in there either. But we really don't want the radical in there. So when we do this, we get 3, radical 3. And down here we have negative 2 times the square root of 9. Well, the square root of 9 is really 3. And if you're noticing, we've got a 3 up here in the numerator and a 3 down here in the denominator. Those 3's really cancel out. So finally here, when we simplify this, we end up with negative radical 3 over 2. So once we know that, I'm going to write it just a little bit better so we can see it a little bit better. Cosine of theta is negative radical 3 over 2. Notice that it doesn't matter. I just moved the negative from the bottom to the top. We're allowed to do that. That whole fraction is negative. But now what we want to know is, really, what does theta equal? So we have to find values on the unit circle. Is she right? We think she's right? What else? If it's pi over 6, then our next one's going to be pi over 6 as well. Once again, so all students take calculus. We want where cosine is negative. Cosine's going to be negative in the second quadrant, and cosine's going to be negative in the third quadrant. Once we can determine the pi over 6, then we can fill in those values. Thomas? And let's go back. We could do 3 sorry, wrong color, but 3 radical 3 over negative 6. But ultimately, we're still going to have to simplify that. And 3 over negative 6 is 1 radical 3 over 2. You can multiply them, in other words. One more. I think that we're getting the idea, and our ultimate goal was to be able to do these problems without the unit circle. But to get acclimated to them, you might want to look at the unit circle for a moment or two to kind of get it in your head of what we're working with so that you can then convert here back to, or find theta. Come on. So as we look at this one, cosecant of theta, well, the reciprocal of cosecant is sine. So we've got 2. So if we were looking at the sine, we need the reciprocal of 2, which is 1/2. So then sine of what equals 1/2? Well, it's pi over 6. And then, because it's positive, then our other value is going to be 5 pi over 6. So go ahead and work on the rest of these for practice.